Imagine for a moment a cosmic clock. Its hands tick not in seconds, but in billions of years. This clock is counting down to the final moment of everything. Not an end in fire, nor an end in ice, but an end where space itself is torn apart. This is not science fiction. This is a serious idea from cosmology. It begins with a force we cannot see, dark energy. It fills space and pushes everything apart, accelerating the expansion of the universe. We found it in the 1990s by measuring distant type Ia supernovae. Today, dark energy makes up about 68–70% of the cosmos. But what if this force gets stronger with time? Then comes the Big Rip. To understand the Big Rip, meet its engine, phantom energy. Regular dark energy is a steady push, like a calm wind. Phantom energy is that wind turning into a hurricane. Its repulsive power increases with time, an ever stronger shove. Cosmology measures this with W, the pressure-to-density ratio. For a cosmological constant, W equals -1. Phantom energy means W. 1, say 1.1 or 1.2. As space grows, its energy density increases instead of thinning. More space makes more phantom energy, which makes even more space. A runaway feedback loop. Imagine a balloon. Regular dark energy is steady air. The balloon expands. Phantom energy is a pump that blows harder the bigger it gets. At first, the stretch is gentle. Then the material weakens, ready to tear. Phantom energy would strain space-time itself. It even violates classical energy conditions. Bizarre, but not yet ruled out. If W stays below 1, the scale factor blows up in finite time. In one model, the Big Rip could arrive in about 22 billion years. About 1 billion years before the end, galaxy clusters start to pull apart. Around 60 million years before, the Milky Way and Andromeda drift apart. Destruction marches from the largest scales down to the smallest. Galactic gravity fails. Spiral arms fling into the dark. The sky thins, stars race away. 3 months before, our galaxy is gone. The solar system drifts alone. 30 minutes before, the sun cannot hold its planets. Earth is torn from its orbit. Stellar gravity collapses. A cascade of silent, universe-wide explosions. In the final instant, forces binding atoms are overcome. Electrons rip free, nuclei fragment, then space-time itself tears. Everything ends. What could phantom energy be? Perhaps a scalar field whose energy grows as space expands. Or interactions between our 4D brain and a higher dimensional bulk. Maybe gravity itself changes at cosmic scales, mimicking phantom behavior. So far, data from Planck, BAO, and supernovae say W, 1 plus 0.05. Current best fit is near 1.03, still consistent with 1. Future missions like Euclid, Roman, and CMBS-4 will tighten the error bars. If W aughts 1, there is no Big Rip, only a slow Big Freeze. Even if phantom wins, estimates place the Rip 22 billion years ahead. The universe may go quiet and cold, or end in a spectacular tear. The search for W is our compass.